We are looking at elementary statistics. Practice test 1, covering module 1, chapters 1, 2, 3. Here's chapter 2, exploring data with tables and graphs. Given the frequency table, answer the following questions. Number 1, the number of classes in the table is. So if you count this, as I've done it here for you, you can see there are 5 of it. So we have 1, 2, 3, 4, 5 categories or classes, number of statistical age groups defined in this case. Class width. In order to find the class width, you can go in a consecutive order as far as the limits. These are the lower limits. These are the upper limits. So you can pick any 2 consecutive classes. And in this case, for example, the first and the second, 21 minus 11. Or if you look at this one, 50 minus 40. And you can calculate the width to be 10. So the width is 10. However, you may even choose one class, any of the classes that you look at. For example, the first one goes from 11 to 20. Then you have to use the upper limit, in this case is 20, minus lower limit, in this case is 11. And then you add 1 unit. Unit could be 1.1 or 10,000, resulting in 10 as a width. We are interested in finding the midpoint for the 4th class. So to find the midpoint, you add up the limits, you divide by 2. So those are the ones you're going to add up, divide by 2, and that becomes a midpoint. Lower boundary of the 5th class, first you find the 5th class, and here's the lower limit. So to find the lower boundary, you have to add these 2 and find the midpoints. In other words, these 2 pieces, add them up, divide by 2, and this is the lower boundary of the 5th class as well as the upper boundary of the previous one, the 4th class. The upper limit of the first class, here's the first class. Remember the first column, lower limits, the second one, upper limits in essence. So we want the upper limit, so it's number 2. Sample size, here's the frequency column, add them up. 5 and 6 and 9 and 11 and 4, just add them up, that becomes the sample size. The relative frequency of the first class. Relative frequency is defined as the frequency divided by the total size, or n. So for the first class, it's 5, and the total, or n, is 35. So we get 5 over 25. Needless to say, in math, we always put the number in lowest term. 5 over 35 is a good start, but it ends up being 1 over 7, and you carry it with many decimals. The number of decimals you carry depends on what they ask you. If they don't, you want to carry many, or you want to keep it as a perfect and exact answer, which is in the form of a fraction. You can set this up with a simple table as follows. So we have this column is the age group, this column is the frequency. So rather than finding a midpoint for one class, you can find the midpoint for all of them quickly as follows. Remember, the width was 10, we found out in the previous page. So in this case, you want the midpoint is 11 plus 20 divided by 2 is 15.5. Just add up 10. Okay. Let's say we want to find the lower and upper boundary for each class. So starting with these 2 numbers, 20 and 21, they add up, divided by 2, you get 20.5. So 20.5 is the upper boundary of the first class as well as lower boundary of the second class. Then all you have to do, keep on adding the width. Remember, the width was 10. So if you keep up with that, and just add this 10, 20.5 becomes 30.5, 40.5, all the way to the end. So you really have one calculation. Also, the lower boundary of the first class, you subtract the width from this and you get 10.5. And what it means, as far as the limits are concerned, any number from 11 to 20, including 11, including 20, belong to this class, as far as the limits are concerned. If you go with the boundaries, anything from 10.5 all the way to 20.5, but not including 20.5, belongs to the first, and 20.5 belongs to the second class all the way to 30.5, not including 30.5. In essence, less than the upper boundary. That's how it is considered. The following frequency table describes the speed of drivers ticketed through a 30-mile-per-hour speed zone. We want to calculate the relative frequencies for all classes. So first, relative frequency, remember it was f over n, which means we need to find the n, add them up, 25, 14, 7, 3, 1. If you add up all of them, you end up with 50. And then, for example, for the first class would be 25 divided by 50, which ends up being 1/2, and you continue 14 over 50, 7 over 50, so on and so forth. Now, 25 over 50 simplifies to 1/2, and you must. So any number that simplifies and reduces, you got to do the same thing. What percentage represents the speed of 53 miles per hour or less? You find 53 as the upper limit of the third class. So anything less than that goes. That's what we want. So these are the frequencies, 25, 14, and 7. So if they were asking for the frequency, you would add them up. Because they want percentage, you divide it by, remember, they want relative frequency in essence, you divide by 50. Therefore, we end up with 92%. So 25 plus 14 plus 7 divided by total size, n equals 50. And as always, you either reduce the fraction or in this case, you represent it as a percentage. The next one is asking for the boundaries. Again, remember what I said, if I want to find the boundaries, I start with this 2, I add them up, divide by 2, I end up with 45.5. Then all I have to do, add and subtract the width. I hope you see the width is, if you go with any two consecutive limits, 46 minus 42, 57 minus 53, you name it. Or 45 minus 42 plus 1, remember, if you use the same one. So I'm going to write all of them just as an example. As far as the width is concerned, I can say, let me write it here. The width is a 53 minus 49, or pick anything else, 58 minus 54. Or if I want to go with this, I have to go with 45 upper limit minus 42 lower limit plus 1 unit, resulting in 4. So now that I have a 4, remember 45 and 46, they give us 45.5. Now I keep on adding 4 to find the rest of them. I subtract 4 to find the lower limit of the lower boundary of the first class. So again, 45 and 46, the midpoint is 45.5. Keep up with adding the width of 4, and you have the rest of it. For the lower boundary of the first class, subtract the width. We want to come up with the histogram. When you want to come up with the histogram, you have the horizontal axis and you have the vertical axis. The horizontal axis is always the midpoints, the limits, or the boundaries. When we do ogive, we always use the boundaries. So I would use boundaries here, but either way will do the job. As far as the vertical axis is concerned, you have a choice of frequency or percent frequency and so forth. You have to read the question very carefully. As we read it here, it says histogram corresponding to what? Frequency distribution. So the height must be the frequency, not percent frequency. So very carefully read this. So the boundaries, we put them next to each other. Okay, remember the lower boundary of the first class was 41.5, the upper boundary was 45.5, and keep up. And you have a bunch of bars adjacent. What is the height here? When we go with the first one, the height is 25. So that's what you get. This is 25. The second one, the height is 14. Look at the height here, 14. The third one, the height is 7, and so on and so forth. So that's how you come up with the histogram. You can do it by hand, you can do it by technology, it doesn't matter. The next question is asking for the cumulative frequency as well as cumulative relative frequency. There are several different ways to write this. And I want to start with the first column here and how we write that. That's extremely important. The concept of a cumulative that basically tells it all. We are interested in all. Therefore, the first class remains unchanged. 42 to 45 is 25. But what happens is that all the lower limits, this is one way, and this is probably the best way, all the lower limits will change to the lower limit of the first class. So I'm going to change this to 42, 42, all of them are 42. So when that happens, the first frequency remains unchanged, but this one is 42 to 49, so we add up these two. This one is 42 to 53, we add up those three, and here's how we write the cumulative. So everything starts with 42, and now we keep on adding. The first one remains as 25, remember that. This one is 25 and 14, then with 7 all the way to the end. What happens is, if we do this properly, the last one must always be equal to 50, or n. Whatever n is the last one. This is how we come up with the cumulative frequency. Now, in some text, they may use this, instead of that, they use the boundaries and they say less than 45.5. That's fine. And you can stick with that according to what text you're dealing with. In some texts, they say less than, and they use the lower limit of the next class. The lower limit of the next class is 46. They might say less than 46. So you may see that less than 45.5. So in some cases, this might change to less than 45.5, or it might change to less than 46, but the next column remains unchanged. As far as cumulative relative frequency, is the same way. You divide by n. N remains as 50. So for this one is 25 divided by 50. For this one is 39 divided by 50. 46, 49, and the last one 50 divided by 50. Now it's very important to notice the last one. The relative frequency must always be 1 or 100%. Always must be 1 or 100%. Always. So we are looking at the same thing, and we are interested in finding the ogive, and then we are going to use the ogive to find the percentage of drivers who drove 47 miles per hour or less. So what is an ogive? The way the ogive works, we have a horizontal axis using the boundaries, starting with 41.5, 45.5, all the way to 61. So that's the 61.5. That's the horizontal axis. The vertical axis, it's always cumulative frequency or percent frequency, depending upon what they tell us. So very carefully read this. It's asking for the percent frequency because you have a choice of putting the frequency or percent frequency, which one, whatever the question is asking. So you want to be very careful as you do that. The lower boundary of the first class will always correspond to 0. The upper boundary of the last one will always correspond to 100% or 1. If it happened to correspond to, instead of cumulative percentage, corresponds to cumulative frequency, then the last one corresponds to n. So take a look at how it works. I want to make sure everybody's following that. Lower limit 41.5, so this always corresponds to 0. Upper limit, upper boundary of the last class. This is always n or 1, depending upon whether we are dealing with frequency or percent frequency. Now, when you look at this number, this one corresponds to the upper boundary of the first class. So take a look. By the way, I hope you see that these are percentage. That's why we end up all the way to 100%. Now, the next one, 49.5, corresponds to 78%. 53.5 corresponds to 92%. 57.5 corresponds to 98%. So you plot those points and then connect them with a line segment. Those are all line segments. Those are not curves. So now we can answer the following question as a result of this graph. Using the OGI, find the percentage of drivers who drove 47 miles per hour or less. So locate 47 along the horizontal axis and find out the corresponding number along the vertical axis. So in this case, 47 is here, and here's the answer. You see that it corresponds to 60, maybe 61% roughly, and that will do the job. Given the following sample, which is the ages of 40 tenured faculty at CSULB, n equals 40, we want to come up with a dot plot and stem plot. So quickly, what is the definition of a dot plot? It is a graphical display of data using dots for relatively small data sets, where values fall into a number of discrete values. Data values are plotted as dots. Along a horizontal scale of values, equal values will be drawn as a stack of dots. So what do we mean by that? It is really helpful if we start with the sorted data. You don't have to do that, but it really makes a huge difference when you do that. Then you come up with a number line. The number line, you can start with the smallest, okay, 32, and the highest is 63, or you can go probably from number 30 to number 65. So you cover all of them. You can even go from negative to positive infinity and just make a dot above those numbers. Either way is fine. Probably from 30 to 65 is more accurate. So as you can see, at top of 32, you have a dot. And this thing continues. What I want to show you is when we get to something like 47, notice we have two of them. So here's number 45, here's number 46. Number 47, we have two dots, and that's my point. If we go to, let's say, 53, we have 1, 2, 3. So we see that 53 has 3 dots, and I hope you see how you do the dot plot. It's very simple, and it's very straightforward. What do we notice? Clearly, the ages range from 32 to 63. That's when we sorted, we can easily see that. Also, there's more tenured faculty at older ages, as you can see more dots here. We're going to do the same thing using a stem plot. So let's see what happens with that. First, a quick definition. Stem plot, stem and leaf plot also is called, display the data in order from smallest to largest. A stem plot, like a histogram, is a tool to help you visualize a quantitative data set. The name stem plot is due to the fact that there is one stem with the largest place value digit to the left and one leaf to the right. We can see the distribution of data while keeping the original data values. So if you want to go with that, for example, we go 3 and then 4, 5, 6, all the way from 3 to 6. And then we put the numbers in front. So first we start with the tens digits. Then we have 32. So we're going to put 2 here. We have 37, and we're going to put 7. 39, we're going to put 9, and we are done. We go to 40. We put that, so on and so forth. So take a look at what happens here. For number 3, we have only 279. For number 4, we have 0, 2, 3, 5, 6. And notice 47, we have 2 of them, so we have it 2 times here. And you keep up with the rest of them. Very straightforward. The last one, 6. We have 0 and 0. We have 2 of them. 1 and 1, 2 of them. 2 and then 3 and 3, 2 of them. And again, the ages range from 32 to 63 years. Also, there is more tenured faculty at older ages.